Mark your own quiz. Here we go. Says this, the diagram below shows part of an electrical circuit. Woohoo! What are the magnitude and the direction of the current passing through resistor R5? I don't know. Let's see what I can figure out. I notice I have 3 amps going this way, coming in, and I have 7 amps coming out. How many amps must I have coming in right there if I'm going to get 7 amps coming out with 3 coming in this way? Gotta be 4. So that means right here I have 4 amps leaving. Oh, how many amps do I have going this way? 2. So how many amps must be coming in if I have 4 going left and 2 going up? 6 amps going which way? Got to be going that way. Number 2. Find the current through R4. These are the toughest type of circuitry questions because nowhere did they give me 2 pieces of information. Those of you that have been working on the homework, you may have noticed if they give you any resistor anywhere with 2 things, the question almost always falls apart pretty quickly. Here, I don't know 2 things, I don't know 2 things, I don't know 2 things, I don't know 2 things. The only way I can do this is to rewrite this as a single resistor. So I'm going to do that. How? First of all, I want to find the parallel equivalent. These 3 are in parallel. 1 over R parallel equals 1 over 18 plus 1 over 9 plus 1 over 3. 1 over 18 plus 1 over 9 plus 1 over 3. And then I take the reciprocal of that. Oh, it's going to be 2. This is the same as 1 single 2 ohm resistor. So mathematically, this is the same as 2, 8. And now they're in series. What is my total resistance in this circuit? R total equals 10 ohms, which means the total current is going to be the total voltage divided by the total resistance. It's going to be 30 divided by 10. Total current is 3 amps. How's that help? Oh, I'm done, because the total current going through here is 3 amps. 3.0 amps, but that's the current going through R4, isn't it? I4 equals 3.0 amps. How would I give you part marks for that, for 4 marks? If I saw this, that would get you 1. If I saw that, that would get you 1. If I saw this, that would get you 1. If I saw that, that would get you 1. B, find the voltage drop across R2. Okay. Well, here I know 2, I now know 3. What's the voltage drop across R4? 24, I times R. How many volts high is my chairlift? By the way, this is the, from last lesson, terminal voltage, not the EMF, because they didn't bother giving me the internal resistor. They're telling me that is my terminal voltage in this particular circuit. Okay. How high am I starting, Emily? What do I lose here? How much high must each of these be? Each one is 6 volts, 6 volts, 6 volts. And B wanted me to find the voltage drop across R2. 6 volts. How would I give you part marks? I guess technically 6.0 if I go to 2 sig figs. I probably won't be too fussy, but let's stay in the habit. If I saw somewhere that you had labeled this with a 24, then I would say I can see your thinking. Okay. Number 3. Find the power dissipated by R1. Again, this is a tough one because nowhere is there a resistor where they have told me 2 pieces of information. I'm going to have to rewrite this as a single resistor. If I'm resketching this, that can be replaced with a 7, and then there's a 3, and then I'll see what I can replace that one with. That'll help me figure out the total resistance. This over here, 1 over R parallel, is going to be 1 over 24 plus 1 over 24 plus 1 over 12. 1 over 24 plus 1 over 24 plus 1 over 12. Reciprocal, that's 6. What's the total resistance of this circuit? 16. Our total is 16 ohms. What's my total voltage? 12. What's my total current? V over R, 12 over 16. Total current, 0.75 amps. Okay. So that means that I have 0.75 amps going this way. Now I have several options. Sean, for what it's worth, I could use the approach that since I have 0.75 amps going this way, I know the voltage drop through here, I times R. But I also know what this is. As one resistor, it's 7. With a current of 0.75, how many volts do I lose going through here? 5.25 volts. Is that okay, Katie? That means that this is 5.25 volts and this is 5.25 volts. In which case, you can now find power because you can go power equals VI equals V squared R. Is that right, Mr. Dueck? Hang on, I better double check. R equals V over I equals V over R. Oh, V squared over R. I can plug this into there if I don't want to bother finding the current. This is the other version of Joule's law. Now, the other thing you could do is you could say, well, because these two resistors are identical, I do have a shortcut. If these two resistors are identical, what can you tell me about the current in each of these? It's the same. So you could go 0.75 divided by 2. You could say, hey, you know what? Each of these is going to be 0.3, what was it? 75. 0.375 amps. 0.375 amps. And now if you wanted to, you could use power just equals VI. What was the voltage in there? Hello, Mr. Dueck, come back. 5.25. What's the current? 0.375. Plus, Mr. Dueck, 0.375 times, come on, times 5.25. Do you get 1.97 watts? Yep. The other way you could have done it is you could have, once you knew the current, you could have skipped the voltage altogether. If you knew that the current split, you could have just gone I squared R, because VI is also I squared R if you plug in an expression for V. In terms of part marks, I can't remember how I marked that one. Let's find out. Quiz 1, version 1 you guys had, or version 2? I guess version 2 is all I have. Okay. So if you got that right, you get full marks. Otherwise, this is what I would be looking for. If I saw that 7, that would give you 1 mark. If I saw that you had written this as 6 ohms, that would give you 1 mark. If I saw the total resistance somewhere of 16, that would get you 1 mark. 1 mark for writing Ohm's law, 1 mark for finding total current, and then I used I squared R because it was easier. Can you give yourself a score on this quiz, please, out of 15? Any questions from terminal voltage? Oh yes, this is when I didn't have my tablet, so I don't have your notes filled out. I have somebody else's. Any you want me to go over from the homework? Basically, Sean, the simple way to treat terminal voltage is treat it like another resistor that just happens to be inside the battery. Okay? But key ideas. We talked about EMF, which is your voltage written on the side of the battery. The EMF doesn't change. That's constant. We can't lower or raise that. It's the terminal voltage, Joel, that changes the voltage that you actually get from the battery. And what does it depend on? It depends on what you hook it up to. If you hook it up to a smaller resistance, that gives you more current, you actually get a lower terminal voltage. Any questions from the homework? Yes. Number 7. Okay. Open. Okay. They want me to find total current. I quickly check, is there anywhere that they've told me 2 pieces of information because the questions really fall apart? No. Okay. When it's open, Connor, all I have is this. Yes? In fact, I think, for Pete's sakes, I think when it's open, the total resistance is 10.5. Dunk and dunk. So I think total current is going to be 20 over 10.5. Right? You okay? I'm guessing you were okay with that part. It's the B that's bugging you a bit more? Or, all right. B. Now when I close it, suddenly I have a parallel situation here. So what I'm going to do is I'm going to re-sketch this. And I'm going to mathematically replace this 5 and this 10 with whatever they're equivalent to. It's going to be 1 over 5 plus 1 over 10, reciprocal. This is the same as a 3.333 ohm resistor, and I still have that little tiny 0.5 ohm resistor built into the battery. I think the total resistance is 3.833. I'll carry a few extra sig figs. So total current is going to be 20 divided by 3.833, which is what? 5.2. I'd like to take this, Connor, one step further. With the switch open, what's the terminal voltage? Well, the terminal voltage with the switch open would be my EMF of 20 minus whatever I lose going through here, which in this case is 0.5 R times, what was the current with it open? 1.9. My terminal voltage, the voltage that I would measure across the battery, would be actually 19 volts, not 20. In the new circuit, my terminal voltage would be still 20 minus 0.5 times, what's my new current? 5.2. I'd have a way lower, I would maybe be measuring a way lower terminal voltage. I'd be losing a lot more energy going through the battery. Is that okay? Any others? 8B. This one here I should not have assigned. Okay? And the reason is this is a short circuit and it's a bit beyond the scope of the course. But here's what really happens. Arvinder, when you close this, because this offers no resistance, the current will not go through this resistor at all. It will take the path of least resistance. It's just going to go through here. So you know what your total resistance is with the switch closed? Not 10.5. Your total resistance is just 0.5 ohms. And your total voltage is still 20. It ends up being 20 divided by 0.5. The current shoots off to 40 amps, which is bad. This is going to get very hot very fast. This is a short circuit. This is why you don't want to build these accidentally into a circuit or into a house. This would either, if this was a battery, it would drain the battery very, very fast, probably about 5 minutes, and you'd feel the battery getting quite warm. If this was a house fixture, you'd be worried because this is a fire hazard right here. Does that make sense? Okay. Were the rest of you pleased that Arvinder asked a question from the homework? Yeah, me too. Any others? Okay, when I go like this and you say the same volume, it doesn't help me. 10, you said? Yes? Okay. Ah! They gave me something, Zay. I bet you this will fall apart, because they told me that 2 amps goes through that guy. What else do I know down here? Instantly, right now. Boom. Too slow. What? I have no idea what you're saying. Okay. More. I don't care about that. Do I know 2 things? Did I know 3? What else do I know right now? Voltage. What? Don't use a calculator for this one. Ah. Oh, Zay. Look. What's the voltage in this resistor? Can we shake hands and meet up? 30 volts this way. This one here has also got to be 30 volts, yes? No, it says through the 15 ohms. Oh, there you go. And now this is going to fall apart because, by the way, that's 30 volts and 10 ohms. Oh, that's 3 amps. Oh, that's 5 amps. So this must be 5 amps. So this must be 5 amps. Now I got the voltage here. And I can figure out all sorts of stuff from there. Is that okay? Oh, yeah, it makes it way easier. If they tell you one piece of information somewhere on a resistor, almost always now, that's the domino that makes the whole question fall apart. Any others? Well, then let's begin the final, no, well, sort of the final unit. I'm splitting it up into 2. The next unit.